Okay, so here's our quick review of position versus time graphs. You've already made your prediction about what each graph represents. Here's the answers for what each graph represents. So keep in mind, the slope of position versus time is the velocity. Slope of position versus time is the velocity. So here we're always staying at the same position. We have a slope of 0, so a velocity is 0. So this one's at rest. Here we have a constant positive slope, so therefore a constant positive velocity. And this one, notice the slope is increasing. So if the slope is increasing, that means the velocity is increasing. So here we're getting faster and faster and faster because the slope is getting steeper, steeper, and steeper. Here, it's the opposite effect. Here, the slope starts off as steep and then becomes shallow, 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 eventually becoming flat, similar to this one. So this is speeding up because it has an increasing slope. This is slowing down because it has a decreasing slope. But both of these show acceleration. This one is kind of a combination of these two. This one starts off with a constant positive velocity and then is at rest. And this one has a constant negative slope, so therefore a constant negative velocity. All right, so the next ones are velocity versus time graphs. So looking at these, now keep in mind, slope isn't the direction something's moving. What determines direction is above the axis or below the axis. Here, slope is the acceleration. Here, this is always the same velocity. It's flat, it's constant. So if I had a number here, it would always be this number. So this is the one with our constant positive velocity. This one has an always increasing velocity because it starts here at 0, and so later on we'd be going really fast. So this is a constantly increasing velocity, and because it has a constant slope, it would have a constant acceleration. This one is our increasing speed, getting faster, but has an increasing acceleration. This is getting faster, but actually a decreasing acceleration. This gets faster with a constant acceleration, then has 0 acceleration. So it gets faster, then moves at a constant speed. This one gets slower because it moves closer to 0. We have speed here, we have no speed here at 0, and we have a constant negative slope, so it's a constant negative acceleration. So this is the constant velocity. This is constantly increasing velocity with a constant acceleration. Gets faster by the same amount every second. This has a constantly decreasing velocity, but a constant acceleration, getting slower by the same amount every second. Okay? All right, and now for that third set of possibilities, third and fourth, excuse me. So here on our position versus time graphs, if the slope changes from negative to positive to negative, if the slope changes, then it's changed directions. So this goes from having a negative slope or a negative velocity to a positive velocity, so it's changed directions. And you can see it, kind of like a bounce. Same with this one, same with this one. So all three of these show a changing direction. The difference between these is this initially moves in the negative direction, then the positive direction, and vice versa. But these have constant velocities, then change direction. This one, on the other hand, slows down because it's curving flat and then speeds up in the opposite direction. So this shows slowing down to a stop, then speeding back up. Okay? With a change in direction. Slowing down to a stop, reversing direction, speeding back up. All right. So now, if we're talking about velocity versus time, by the way, these two, before I get to that, notice these have a constant slope the entire time. So this has a constant negative velocity the entire time, constant positive velocity. The difference between these is this goes past the origin, is just the only difference. Okay, and so finally, velocity versus time graphs. If we're looking at velocity versus time graphs, this does not change directions. This slows down to a stop, speeds back up, but never changes directions. This is what has to happen for it to change direction. On a velocity versus time, it has to go from positive to negative. Slow down to a stop, speed back up in the opposite direction. Same thing with this. Slow down to stop, speed up in the opposite direction. Difference is this might be what starts in the positive, then ends in the negative, but the slope is always negative. Same thing with here. Starts in the negative, ends in the positive, but the slope is always positive. Constant acceleration, velocity changes direction, velocity changes direction. Here, slows down, speeds up, but never changes direction. So this is like the stop sign. Same thing with this. This one right here speeds up, then slows down, but never changes direction. This one, speeds up and then slows down, but never changes direction because it never crosses the axis. Okay? So that's the explanation of the four problems you had before. Hopefully you got them all right. Good luck.